Well, hi, everybody. My name is Denny. Glad to really be here. I believe we're supposed to be playing because these are recorded. We're actually live, but because Paulo is in Tokyo and I'm in Seattle, so it's currently 1 in the morning, we've thought that maybe, at least for myself, it probably didn't make sense for me to go ahead and try to do the demos in my current mental state. So hence the reason for doing some of them as recordings. But we will definitely be online to answer questions. A little bit by myself. You might also hear it in the recording. Well, I'm a developer advocate at Databricks. Prior to that, I was Senior Director of Data Science Engineering at SAP Concur, and also I was on a bunch of engineering teams at Microsoft before that, including what is currently known as, including Project Isotope, what's currently known as Azure HD Insight. So even though I was working for the big evil empire, I actually was very much an open source guy right from the beginning. So that's a little bit by myself. Paula, why don't you chime in here?
All right, thanks, Denny. So yeah, I'm Paulo. You'll also hear a little bit about me in the introduction. I'm currently based in Tokyo. I work at Databricks as a solutions architect. So before joining Databricks, I was lead data architect at Rakuten in Tokyo. So I led engineering teams, data engineering, data visualization teams in building Rakuten's in-house analytics platform. So yep, right now I work at Databricks about a little over a year now. And yeah, I'm very excited to, as Denny said, answer your questions. If you have, we're going to go through some hands-on workshop in the afternoon, in the second half, I'm sorry. And yeah, so if you have any questions, issues, please, I guess, type them in through chat and we'll try to be helpful as much as we can. Thank you.
Perfect. Okay, well then let's start the show.
Hi, my name is Paulo, and I work at Databricks as a solutions architect based in Tokyo. Today, I will take you through MLflow in the second half of this tutorial. We will be using a notebook on a Databricks Community Edition to show you and for you to have a hands-on feel on how MLflow can simplify the machine learning lifecycle. Hopefully by the end of the session, you would have a clearer picture on how you could use MLflow and maybe Databricks in your day-to-day job.
Thanks very much, Paulo. My name is Denny Lee, and I'll be the other co-host for today's MLflow tutorial at VLDB 2020 BOSS Tokyo. A little bit about myself. I'm a developer advocate at Databricks working with Apache Spark since 0.7. Prior to joining Databricks, I was the Senior Director of Data Science Engineering at SAP Concur, and before that, I was part of the engineering teams at Microsoft, including Bing, SQL Server, Azure Cosmos DB, and Project Isotope, the incubation project that is now known as HD Insight. I also happen to have a background in healthcare life sciences, including a master's in biomedical informatics. So with that out of the way, let's start the show. Welcome to our BOSS MLflow tutorial for VLDB 2020. While this may seem like a relatively unexciting topic, one of the main problems as a data scientist is to simplify the process of machine learning from tracking all of your hyperparameters and metrics to your model versioning. As noted previously, this session will be broken into two components. This session will be more slide-centric, where we discuss the concepts. For today's session, our agenda will initially be about the broad adoption of ML and all of the issues that come with it. Due to these issues, there is an apparent need for standardization, if for no other reason so you can actually compare the efficacy of different models. even when you standardize, there are a number of challenges as you develop your machine learning models and go through the process to deploy them into production. Finally, we will discuss how MLflow tackles all of these issues. So before we get into this though, let's start with logging in to Databricks Community Edition. So as you can see here, go to https://databricks.com/try. At this point, you'll be able to sign up for Databricks Community Edition for free. We're going to use this for your tutorial, and then once you sign up, you can continue to use it to learn and experiment on your dedicated data science engineering environment. So again, databricks.com/try. I'll wait a few seconds for you to jot this down, and so we can continue. So start by signing up for Databricks Community Edition, or DBCE, by going to databricks.com/try and filling out the initial profile form. It'll look something like this. Then when you get to this page after you fill out the profile, note that you're going to want to click on the right side, or the side that's Community Edition, Get Started for Free, okay? It's not the green button with Azure and AWS, it's the white button, or at least perhaps it's changed, but the point is it's the smaller one. That's the one that's for free and does not require your credit card. So remember to click on the Community Edition, not the Databricks Platform Free Trial, okay? Community Edition, that's the one you want. Okay, when you do sign up for it, it'll actually email you a new link, okay? And from here, basically, it'll look something akin to this, okay? And then once you go to community.cloud.databricks.com, you'll be able to put in that email address that you typed in with your password that you typed in, and then you should be good to go. If for some reason there are issues, you can always click on the new to Databricks sign up right below the sign in to re-sign up again, okay? And once you've logged into Databricks, the workspace should look something similar to the one you're seeing right here. Again, it might look slightly differently, but this is more or less what it'll look like. There'll be a workspace, home, workspace, recents, data, clusters, jobs, and search. That'll look something like this. Okay. Now, again, you'll be able to go ahead and do this during this first 30, 40 minutes because we're going to be discussing some concepts. And then afterwards, when we kick off the tutorial, we want to make sure that you've already logged in, okay? And so, but just in case, I'm also adding some additional steps, like for example, how do you create a cluster on Databricks Community Edition? To do that, click on Create a Cluster on DBCE. For example, on the left side, you'll just literally click on Cluster, and there'll be a little blue button that says Create Cluster, okay? Now, note, when you're using DBCE, you have a single node instance. It's not really a cluster per se, but whether you're using, DBCE or enterprise version Databricks, which can span hundreds of nodes without any problem, the first thing you have to do either way is to create a cluster. So that's why I'm saying start with that, okay? And this will bring up the create cluster dialog, as you'll notice here. And so type in the name and stick with the defaults for now. In this case, it'll probably look something, this is an older screenshot, but probably choose the one that says Databricks Runtime version 6.6, okay? So I happen to choose a name called Delta Rocks. And the runtime at the time that I wrote this was 6.1, so the version for our tutorial will be 6.6, okay? Oh, right, and I'm sorry, 6.6 ML. Okay, let's be very clear. You're going to want to do the 6.6 ML machine learning because that actually includes the machine learning libraries, okay? So that's the one you'll actually want to run. Once you create the cluster up, it'll take a short while to do it, but it'll look something like this. You'll see the nodes. Now, this is again an older screenshot. What will end up happening is that you'll be provided with 15.3 gigs of RAM with 2 cores. Okay, that's what your cluster is going to look like, which is again not really cluster, but either way, that's what it's going to look like. From there, the cluster, the node will be up and running for about 2 hours before it shuts itself down. Okay, so that way we save money. All right. Once you want to go work with this, you're going to attach a notebook. Now, we're going to provide those instructions as part of the tutorial, but just in case you want to go do this, the easiest way is to go ahead and in your workspace, right-click the folder button and then click on Import. Right, that's what you're going to do. You're going to right-click on any folder or any space in the workspace. You're going to click on Import. Once you choose Import, you'll be given a dialog similar to this. Okay, you can either attach a file directly or you can drop a URL. We're going to drop you in a URL. That's what it'll look like. Paste the notebook URL basically from the screenshot that we're going to give you. All right, so the notebook URL will be provided to you, so that's actually how it's going to look like, by the way, okay? And then once you have it, then it'll look something similar to this, okay? So that's just a quick context of getting yourself up and running. Again, sign up for Databricks Community Edition to get yourself up and running so you can go do this, okay? All right, let's switch gears and talk about the broad adoption of machine learning next. Okay, let's get back to talking about the broad adoption of machine learning. The reason it has taken such high importance for many companies is because the companies that are successful with machine learning are able to disrupt the status quo. That is, they'll be able to provide new services and or new capabilities that others were not able to find or build new market segments that previously did not exist. So note, while the excitement of building these new algorithms, and for that matter, the associated new business services is all the excitement, all the rage, the reality is there's a lot of boring work that needs to be done to do it successfully. And I'm sure you've all seen this particular slide numerous times, but it makes sense to overemphasize this point that the machine learning code that we are all excited about is only this little green box in the technical process and technical debt that's machine learning. There are so many other things that must be done first before you can actually perform your machine learning tasks. And so the first thing we want to talk about before we even get into the technologies themselves is let's start with the definition of the people and their roles. In any data science project, you will need data engineers and data scientists. Data engineers work to organize and make sense of the data in relational databases, NoSQL databases, storage systems, event processing systems, and using more than one of these set of technologies. Okay. Meanwhile, data scientists take that data and they have their own set of technologies, including but not limited to Keras, TensorFlow, PyTorch, Scikit-learn, and others to run their predictions. A major problem or major issue is that they often work in silos. They don't work together, and they're working on very different technologies. But this isn't conducive to delivering high-quality results when the people working on the very same data are separate from each other. So our life cycle around machine learning is manual, inconsistent, and very disconnected. Here's a very simple example. We start by preparing data using Apache Spark here on the left. But even if we were to perform all of our data integrations and data engineering, it's difficult to track which data is used to run models downstream. In the middle, our data scientists then builds the models using a different set of technologies that may or may not have anything to do with the preparation of the data. None of these technologies by themselves allow us to properly track our experiments, so it becomes exceedingly difficult to reproduce these experiments. Presuming we have some manual tracking of the data version or the correct hyperparameters for a model, now we have to go deploy it. So it's back to the data engineer who's working with another set of disparate technologies in order to deploy it. So making it even more difficult is the fact that monitoring each framework has its own set of complexities and they all work very differently. So it's very apparent that there's a real need for standardization between these three components so you can prepare the data knowing the impact of the downstream models. So what's the day and the life of a data scientist when it comes to tracking your ML model? For example, did anything change in feature engineering? Like when I'm looking at these missing values here, what happened for these changes? Did I change the features that were used for my model? Or perhaps maybe my hyperparameters had changed. For that matter, why did they change? What data was this model trained on? What version of this data? What time frame? Is it the same source as the commonly shared version, or is this a custom version of the data set? How did the offline metrics change? And even if I could find the reasons for the rest of it, why? Well, why did it change? What's the impact? And of course, the crucial question, what else am I missing? And this is just it's a relatively simplistic showcase, but the idea here is just to talk about the fact that, if you're working with your own little experiments, perhaps you can just track that all down in Notepad, because you're the one being the data engineer to parse the data. You're the one that's being the data scientist to try different models and so forth and so forth. But when you have a team that's all working together on this becomes exceedingly difficult because we can't really trade back and forth notepads. Okay? So let's switch gears a little bit here, okay? And compare the machine learning lifecycle versus the software development lifecycle. While it may seem obvious that there is no difference, in fact, the differences are stark enough that it entails its own parallel process. That is, the release cycle of deploying machine learning models must be done in addition to the software lifecycle. So let's start with the software lifecycle. For those of you who are not familiar with it, it starts with writing a code, writing your unit tests, sending it for review, getting approvals, committing it, and release it for testing, and then finally releasing it. If we were all together in the same room, I would ask you how many of you actually have processes built up to do all these steps. And I'm sure some of you have, but you have to admit that the vast majority of data scientists and data engineers lack a formalized process for deploying their ML models. For that matter, I doubt that the vast majority of data scientists have unit tests for their machine learning models. But if you think about it, in addition to the actual software development lifecycle for code, there's a separate, equally important set of steps that require for deploying your ML model just beyond just unit tests, reviews, approvals, and release. As you can see the flow on the right side here, it starts with the analysis of your data. And to do this, the first thing you do is to put the data into the correct format. That is, you apply some schema to the data set. Excuse me. That is that you will apply some schema to the data set that your ML code can properly make sense of it, whether it's CSV, JSON, Parquet, or database. Then you will choose the desired ML library, write your code, and then train and evaluate the model. But throughout the process, you will iteratively experiment with parameters and model structure. This isn't a one-way approach. For each of the previous steps, you may go back to the beginning, including reanalyzing the data based on what you've discovered in each of these steps. You will restructure your data for analysis, rewrite your ML code for different parameters, including changing libraries altogether, when you realize a different approach is warranted. Then, once you've chosen your model and its associated hyperparameters, how are you going to deploy the model? Even if you have a straightforward mechanism to deploy it, you will need to monitor the performance of the model as well as any of the new data that comes in to retrain the model as time progresses. In breaking these cycles down to their most fundamentals to visualize the parallels, when you write code in the software development lifecycle, it begins with the functional specification. In the case of machine learning models, the goal is to epitomize some metric. Both require some form of definition or objective that you need to meet. Just like in software development, the quality of your ML model depends on the code as well. But to further strengthen the complexities, it also depends on the quality of your data, how well the model itself is built, and the hyperparameters that were chosen. In a Google paper in the past, it had been noted that The more high quality data you had could often impact the quality of your predictions when compared to high quality models, but using less data. There's a reason why so many data companies are trying to record as much data as possible. It's all to help their ML models, machine learning models, make better predictions. In the case of software, often you're able to stick to a single software stack or a few pieces of key technologies. On the other hand, the diversity of tools within the ML ecosystem is immense, and keeping track of which versions of libraries work well with the other, how can they work together, itself is often a very logistical nightmare. And finally, the most painful aspect of machine learning development is that while software development works deterministically, the outcome of your machine learning models will keep changing as new data comes in. So even if you're not joining the data with other data sets, your machine learning models will invariably change as your data changes, whether by retraining or needing to use a model altogether. After all, as your model makes predictions, the feedback loop from running these predictions can itself be used to make the predictions better. So, as you can see, deploying machine learning models is hard. In addition to the following software development lifecycle, ML models have their own life cycles, and that must be performed in parallel. What's brutal is that often machine learning practices result in doing only a little of one cycle or the other, and the reality is that both are required for a continuously successful machine learning lifecycle. So don't worry, we're not going to go through this entire slide. We left the slide here just to emphasize the lifecycle and all of its challenges. In addition to the constant revision and retraining, this is all running on top of a plethora of frameworks that do not necessarily work well together. The data engineering and data science community are working hard to see if we can simplify this, but the reality is this is going to take some time. And even if you're able to simplify the technology choices, you're going to need to constantly tune, retune, deploy, monitor, and manage your models, and then rinse and repeat. Okay, let's get back to talking about the broad adoption of machine learning. The reason it has taken such high importance for many companies is because the companies that are successful with machine learning are able to disrupt the status quo. That is, they'll be able to provide new services and or new capabilities that others were not able to find or build new. So back in 2018, we unveiled MLflow. It's the only open source framework designed to manage and the complete machine learning lifecycle. You notice that there are actually 4 components of it: MLflow tracking, MLflow projects, models, and the model registry. We're going to discuss all 4 of these components today. MLflow is actually one of the fastest growing projects in terms of contributors, especially since the launch of the project. For example, if you look at Apache Spark, the number of months since the project launched in order to be able to hit 140 contributors. MLflow hit that in less than a third of that time, which is pretty impressive to say the least. So why is MLflow so interesting? Well, it's because its components really are as noted here. It's about tracking, projects, models, and model registry. The tracking records your query experiments, whether it's the code, the data, the configurations, or the results. Projects is a packaging format for reproducible runs on any platform. The idea is that we will take all the components that you use for your machine learning model, package it up, And so that way you can move it to another system and be able to successfully reproduce the exact same results because you're using the same versions of all the packages. When it comes to the models themselves, it's a generalized format that standardizes the deployment path. So that way it's possible for you to grab a model, pickle file, or whatever it is, and be able to deploy it or use it. Now, even with all that, another very important component is the model registry. The ability to centrally collaborate the model lifecycle management. The idea that you can put a model up, store it, run it, and so forth and so forth, okay? The idea of being able to swap out different models. We're actually going to demo it real quick before you run it as a tutorial to give you an idea how this all works. And so, in the case of MLflow tracking, as you can say, it's a tracking server that tracks all your code, your configurations, the parameters and the metrics, whether it's in notebooks, local apps, cloud jobs, no problem at all, okay? The key concepts for tracking is this. We're going to take your parameters, the key values of input to your code, your metrics, your artifacts, and what source your code ran on. We're going to run a couple of demos real quick just to showcase that. But the important thing is, for example, what does your code look like? So I'm just using this example of using scikit-learn's linear regression by ElasticNet. This is what your code base looks like, okay? The modification to your code with MLflow is to simply add this. With MLflow, .start run as run, and then logging the parameters and the associated metrics as well. That's it. That's the only real difference. We're going to show a demo in the next section. As right here. Okay, so let's start with this demo as we showed. It's actually here on my GitHub page in MLflow diabetes example. So we're just going to initially run it directly ourselves, okay, using train-diabetes.py. The code base basically looks like this, and in fact, it's actually the standard scikit-learn ElasticNet linear regression model that you have. I've just only added these commands. You'll notice that it says import MLflow, MLflow sklearn. I also added the commands MLflow here, okay? So in other words, log the parameters, alpha, L1 ratio, RMSE, R2, MAE, and the model itself. Otherwise than that, there wasn't that much difference. I did probably also add a visualization inside here, this figure here about the ElasticNet paths. And then I also logged it, okay, right here on this last command here, okay? Otherwise that, there's nothing terribly interesting here, actually, honestly. So, all right, so in terms of MLflow, it's just adding these little bits of parameters. Okay, so let's go ahead and minimize that for now. So we'll just start here, okay? So, all right, well, it's pretty easy to run. We just run Python train-diabetes.py, and so this is me just running in Python normally. And so what you have here is the calculated the RMSE, MAE, and R squared. I put some default values for the alpha and the L1 ratio. If I'm going to run the MLflow UI, this is after I already installed it. And by the way, if you want to install it locally, just go pip install MLflow. That's actually all you have to do to install it locally in your box. But I'm just going to go ahead and take a look at the UI real quick. Okay, so it'll spin up. I'm going to go ahead and go to this folder here. I'm sorry, this browser window here. Give me 1 second. Boom. All right. And there you go. And so you'll notice that I just added something here. I actually have some older dates here from the last time I ran this particular example, but you'll notice it right here. This is the one I just ran. So let me go click on it. And you'll want to notice that, see, even the git commit, the date of the file, train diabetes that I used. Here's the alpha and L1 ratio, the parameters that I used. Here's the RMSE, R squared, and MAE values that I have. Included with it is the ElasticNet visualization that I talked about, which you can download if you want to, but also the models itself. The model, actually the model here is the pickle file right here. You have the conda YAML that tells you which version of Python and scikit-learn I was using, as well as MLflow and Cloud Pickle. And if you dive into the model itself, and you'll notice that, again, we call out which version of Python. The MLflow sklearn is the loader module with sklearn, all the different values, including the run ID. So it gives you a really quick way to be able to figure out how to run this stuff, which is pretty sweet. But how about if I didn't want to install my code? Okay, I didn't want to download this. Well, here's a pretty cool example. So I'm going to go ahead and copy this second line, MLflow run. Okay, it's actually using the same thing. Okay, I'm going to go ahead and minimize this again. I'm going to cancel this, and I'm going to go to a completely, different folder here. Okay, all right, perfect. So there's nothing here. Okay. All right, so nothing's here, and so I obviously can't run this. Not a big deal. I'll just simply go ahead and paste this, run. What will happen here is that MLflow will reach out to my GitHub repository, download the necessary libraries, and run it itself. And so you'll notice that's actually what's happening. It actually created this directory here, okay, for downloading all the information it needed, all the library versions, and was able to successfully run it as well. And if I actually look at the folder here, there's still an ML runs folder. I'm going to go ahead and run the MLflow UI here and open it up. Again, we'll go back to this folder. Excuse me, browser window. There we go. Sorry about that. And click on here. You'll notice that actually how the run is here. It actually tells you exactly what was inputted, including the alpha and the L1 ratio, the git commit, all the information, MEE, R squared, RMSE. These are slightly different from before, but it's all in here, including the visualization. Oops, sorry. Haha. All right. There we go. And the models that we were working with. Okay, so pretty powerful stuff and a great way to be able to jumpstart yourself with MLflow. So what's great about MLflow is that in addition to being able to track all this, we actually have various scatter plots, contour plots, parallel coordinate plots for you to be able to make sense of the data, make sense of which metrics were actually helping you or maybe not. So the whole purpose of the project now is that it's a spec. As you just saw on the demo, we actually packaged everything together. So the code, the configuration, the metadata, all of it's there such that way you can have local execution or remote execution. It doesn't really matter, actually. And so, for example, if you look at an example MLflow project, inside what you see the conda, the ML project, excuse me, you see the conda YAML, its entry points such as what parameters were being used, what commands being used, the actual Python files to run your models. Okay, so. And then just as you noted in the previous demo and the upcoming demo, basically you can just run using MLflow run git, right? And as opposed to actually needing to download the entire package yourself, you can just use MLflow run. It will go to GitHub, download the package, run it for you, download the package, download all the appropriate versions of machine learning libraries that you want to work with inside its own virtual environment. Run that, and then boom, you still will get the exact same results, which is pretty nice. So how about the MLflow models? Well, the models basically, it allows you to take all the different libraries that you see here, and now you're able to go ahead and choose different flavors for your models. So you can associate that to TensorFlow or to Spark or whatever else, such that the downstream systems are actually able to go ahead and make use of it, right? It understands whether it's Docker or inline code or batch or stream and storing or cloud inference services like Azure Machine Learning or AWS SageMaker. It's just able to go ahead and understand what flavor of the model that you have. And what do I mean by flavor? Here it is, right? So for example, in the ML model, we have the run ID that tells you exactly which run it was, when it was created, what flavor. In this case, we're saying, for example, it's a TensorFlow flavor. All right. So then it'll be usable by tools that understand the TensorFlow model format versus something like a Python function will be usable by any tool that can run Python, Docker, Spark, whatever else. Right. So having that flavor really tells us what's going on. And then finally, we want to actually have a registry that actually stores which models that actually you have, and you'll be able to keep track of them and change appropriately, because the cycle between data scientists and deployment engineers, that it's not a one-way street. It actually can rotate, between the downstream users, whether it's an automated job. You need to do REST serving for that matter. Okay. And so the benefits is that you have this central model repository. You have an overview of which models are being staged versus which ones are in production. And you can easily search and filter paginate these things. So the other benefits include the ability to know what are your active models and their deployment stage, and request approval for the transitioning to of the deployment stages. And we're going to demonstrate that very shortly, actually. Finally, you actually have a full activity log. You can see exactly what happened. So in this case, Clemens went ahead and applied to take this particular model from none to production, and then it was actually requested to stage the transition from production back to none. Okay, so and it was, for that matter, even rejected a stage transition. You're able to see log exactly what the approval process were, right? And then because you want governance and accountability, you know exactly what run that produced that model, what notebook version that produced that model, exactly that revision history, and you even can go back in the edit history of the notebook to figure that out. Okay, so pretty powerful stuff, and you can definitely take a look at this demo, which we're going to go showcase in a second, in order to understand how this works. Okay, so let's go back to demoing the same diabetes example that we have with scikit-learn, except we're going to use the model registry. So the code base is actually exactly the same. We just copied it over to our notebook. These cells that I'm actually running here, which I've hidden for now, is just because I'm going ahead and doing some of the visualizations you see. So for example, these elastic net paths, I just added some additional code for that, okay? So let's go run this example now, okay? So run info1 train diabetes. Again, as you can tell, I'm putting specific alpha and L1 ratio values here, okay? And the outputs here, the RMSE, MAE, and R squared. And you'll notice that basically there's a little dot here that tells you that the MLflow tracking UI has automatically figured this out, which is pretty cool because there's actually scikit-learn integration within MLflow now, so you don't even technically need to go ahead and add the additional code to figure that out. But nevertheless, let's go ahead and run this, and this is what the image is going to look like. We're going to run another one with a separate set of values, okay? So with 0.01 and 0.75. The R squared is going up, I think. Yes, it's going up. The RMSE is also going down, all right? And so here's what the image looks like here, all right? And let's go with 0.01 and 1 as our values for sake of argument. All right, so R squared is even closer to 1. Well, it's higher, I should put it that way. 0.395, RMSE is a little bit lower. At least I believe it is. Yes, no problem. Okay, so perfect. And so you can keep on running. I'm actually going to skip these two steps. There's really no reason for doing it. But now let me look at the UI. Okay, so there's actually an animated GIF that showcases it, but we're just going to skip past that part. Okay, we're just going to click on this, and we'll see all of these cool experiments. No problem. Let me just pop it open, and you can actually visualize this a little bit better. So here are the last 3 experiments. We'll just use on the 31st. Okay, click, click, click. We can even compare the 3 of them, and so we can take a look at the metrics. Instead of alpha by MAE, let me go ahead and use R squared and using the different alpha values. So you can tell, right, basically by just dropping here, hovering over, you can look at the values this way. Maybe I can look at it through RMSE, and maybe based on the L1 ratio if I wanted to. Same idea, okay? All right, and then for that matter, if I wanted just to say, hey, which experiments works better, let me go ahead and use, look at just R squared, okay? So, all right, cool. So the last run with the value of 3.395 is the best one, but let's just go with the first run, just because I decided to be very silly. Okay, so let me just click on that, all right? Click on that. Here's the actual model. Now, I'm actually choosing probably not the best model, but that's okay. Just as shown in the previous demo, here's the model, okay? Here's the visualization, here's the model. But what's great about this is if I click on this, I can click on Register Model now. So when I click that, let me go ahead and choose. All right, perfect. click on register, what happens, you'll notice that this version 5 of the model's kicking in. So let me click on that. Bam. All right. And so this will open up, and sure enough, it'll tell you what stage. Right now, there's no stages, okay? So, but it'll tell you exactly which model I'm working with, all right? So I'm going to transition this directly to production right away. So I'm going to click on that. I'm going to say, boss, tutorial, demo 2. All right, click on OK. All right, boom. Now I've transitioned it. So if I go back to the diabetes example, here's what's going on, okay? So I have 4 versions. I created this 5th version. I created a 4th version yesterday for that matter, okay? This is the only active one that I have right now, all right? So it tells me everything I need to know. So let's go back to this, all right? So if I was to copy this path, okay? All right. Actually, just in case, there we go. Okay. All right, go back here. I'm going to close the experiments. If I wanted to, I could just access the model directly, okay? All right, and see the model, okay? And that's great, okay? And then I can run the predictions against that model, all right? So it predicted for this one, for that matter, 164.63. All right, that's great, all right? But how about if I wanted to run the model from a model registry instead of actually specifying the exact path, because I might want to have my code base decide based on what was placed in the registry, which is in this case version 5. I'm going to go ahead and click on this. And sure enough, because I've specified this with this little code base, I've told it what the model production is, and here's what it is. Okay, now I can run the exact same code base and predict with the same value, which is great. Okay, except I know that this model's probably not the best idea. Okay, so this is what I had before. Okay, so this is what it is now. So I'm going to go back and I'm going to switch it to version 3 because I think this is a better model. So I'm going to go ahead and transition this instead of requesting, because you could request it if you don't have the rights to do it, but in this case for a demo I do. I'm going to transition this to production. All right, boss, tutorial 2, demo 3. There we go. Click OK. And so now let's go back to the diabetes example. Now we know this is the one that's active. So let's go ahead and run. Exact same code as above, okay? Except now I'm just going to show it here. All right. So it's pulling in that model from MLflow Diabetes production. And then when I run it again, this time I'm going to have a different value. And that's actually pretty cool because then the data scientists and data engineers that are in charge for deploying the models, they can control the models that's being used through the registry, while at the same time, the application developers that actually are using the model, they may not necessarily know which model they're supposed to be using. That's okay. Because they're accessing the registry, they're able to go ahead and use the latest version as determined by the data scientist and the data engineer. Hope this helps. So that's really it before we go into the tutorial section. So we want to really leave you with this thought process that MLflow is an open source machine learning platform towards a more principled data science and machine learning. So if you want to learn more, go to mlflow.org. Check us out at github.com/mlflow or twitter.com/mlflow as well. All right, now back to Paulo.
Thanks, Denny. Okay, now that your cluster is up and running, you would see that it's up and running when you see a solid green icon there. We're going to go through the actual notebook. So this notebook is a Python-based notebook, which means the default language.
Sorry, can we play the video before this one? Thank you. It should be 06. Yes, thank you.
Thanks, Denny. So now we will move to the next part of this workshop, which is a hands-on workshop. I believe Denny has asked you to create a free account on the Databricks Community Edition. If you haven't done so, please do so now, as this is necessary for you to do the hands-on workshop. Otherwise, you can also follow along as I go through the parts of the notebook, and then you can set it up later at your convenient time. So let's go. First of all, I'd like you to access this URL. Right? So the URL should take you to a published notebook, to a public notebook hosted on our servers, and you will have the MLflow Quick Start notebook. So here, let's copy the URL so that we can import it into the Databricks Community Edition. You can copy the current URL on your browser, or you can also copy it from the import notebook shown on the top right side of this published notebook. So let's go ahead and do that. Once you copy it, click Done, and let's go to the Databricks Community Edition, which is community.cloud.databricks.com/login. So here, I signed in, and it should take you to the Databricks environment homepage. Here you have a bunch of features, some user settings on the right. You have some features on the left that I would not go through in detail. First, before we import the notebook, let's go ahead and create a cluster, which we would use in a bit. So let's have create cluster, MLflow, boss 2020, or whatever name you want, and you pick the Databricks runtime version. Again, as Denny mentioned earlier, let's create a 6.6 version runtime, and let's pick ML. Again, the main difference between the plain version and the ML version is that the ML version would have most commonly used libraries for machine learning pre-installed in the runtime. These could be TensorFlow, PyTorch, or any common machine learning libraries. And if you want more details, you can look at the website for what is pre-installed in an ML runtime. So let's go ahead and pick that and click Create Cluster. So in a few seconds, you will see the clusters being started here. See that? And while we're waiting for it to start, let's go through the workspace. Let's go to the home, and then let's pick users, right? You should have your email registered here. And just for the sake of cleanliness, I created a different folder so that you won't be confused. So here, under this folder, right, you can click this down arrow and click Import. Okay. So here you have the option to upload .dbc, which is a proprietary Databricks format, or some open formats like .scala, .python, .sql, or etc. You can also import Jupyter notebooks here, as you can see. But this time, since we had the published notebook earlier and we copied the URL, we can also use that to copy or to import the notebook into the environment. So let's do that. Paste and then import. All right. So you should have a notebook similar to what you see on the screen. This is the notebook that we will be going through for the rest of the tutorial. So here you have different options like file, you can clone it, rename it, move it, and other things that you can do with the actual notebook. There's edit as well. You can cut and copy cells, move cells up or move cells down, etc. And this view option is something that I use quite frequently as I want to see my results side by side, especially when I'm working on a landscape orientation. So let's do that. So if we do that, you see the code on the left side and the results on the right side. So this is specifically helpful if you don't have a portrait orientation screen. And then you have the options to run all. And if in a full Databricks version, you would also have the options to set permissions for visibility and being able to edit notebook, etc. On the right side, you would have the option to publish this notebook. Say you made some changes and want to republish it, you can do so, and we will host it for you so that you can share it to another colleague, or you can even use that to import the notebook into a full version of Databricks. And then you have the options to comment as well. See, you can, if you maybe ask your colleague to review your work, and he can leave some code suggestions, he can leave comments here as well. Experiment is something that we will use quite a lot in this tutorial, where we can see parameter tuning and how the metrics change based on what we change in the parameters. And then finally, you have the revision history, which gets automatically saved whenever you run something, or whenever you have a checkpoint, it would automatically save it for you, so you can go back to a previous version of your code. Okay, so by now, you should have the cluster started. So let us attach the cluster into the notebook.
Okay, so I was thinking maybe while waiting for the clusters to start up, we can have a quick 2-minute break to stretch. I know it's going to be a bit of a long session, and I also wanted to use this time. If you have any issues setting up, please let us know. And so we're gonna restart in 2 minutes. Please let us know if you need help. Otherwise, please go ahead and stretch, and let's get those blood flowing. All right. No questions in the chat, so perhaps we can restart. We can continue with the next video.
Okay. Now that your cluster is up and running, you would see that it's up and running when you see a solid green icon there. We're going to go through the actual notebook. So this notebook is a Python-based notebook, which means the default language is using Python. Alternatively, you can use Scala, SQL, R, whichever you're familiar with or more comfortable with, to change the default language. So if you don't specify anything, it would be recognized as a Python command. Let's look at the first cell. So the first cell says %md, which basically tells the cluster that this is a markdown command, very similar to a Jupyter notebook. So if you run that, you would see that it would show you, or you would see the results as markdown. So again, this is a quick start notebook, and it's based on some very basic concepts in the MLflow tutorial. So earlier, Denny showed us how to run an MLflow server using the open source version. But this time we will be using a hosted version on Databricks, Community Edition, which has things integrated into the notebook, for example, experiments, and you would also be able to see the MLflow UI later. And so everything is integrated into the platform, and so you don't have to run things in separately or independently. So in this notebook, we will show you how to log certain things like metrics, parameters, and models, and even some arbitrary files like an image file that you can use as artifacts later on. We will also show you how to deploy the model as a Spark UDF, and also look at our results, look at the results of changing parameters, etc., into a tracking UI of MLflow. Finally, we will show you how to manage models with the model registry. And since model registry is not available in the community edition, I will switch over to our demo environment to show you how it's done when you're using a full edition, non-community edition version of Databricks. So this notebook uses the diabetes dataset in scikit-learn, and it would predict a progression metric using the scikit-learn ElasticNet linear regression model. And so we will show you how to change the parameters and also show you how that affects the metrics and how we can track that using MLflow. If you're not familiar with ElasticNet, I put some links here that you can look at after the session. So let's jump right in. So the first cell here, or the third cell, technically, is basically just a Python code that imports all the necessary libraries that you would need to build this model. So you see here, we've imported pandas, numpy, scikit-learn, matplotlib, MLflow, of course. And if you noticed, we didn't have a step where you needed to install this one by one. And this is because we used the ML runtime, if you remember. We used the ML runtime, which has all these things pre-installed for you. In the cell, we also load the diabetes dataset and assign it into a pandas data frame and assign it to the data variable. Okay. So let's go ahead and run this cell. To run cells, you can either go to the top right and click Run Cell. Otherwise, you can also use a keyboard shortcut similar to or the same as Jupyter. Click Shift Return, or in Windows, maybe it's Shift Enter. If this is your first time executing it, you might spend a few seconds attaching it to the cluster, but otherwise it should take a fraction of a second. So after we have imported the necessary libraries that we need, we will start declaring reusable functions, right? And so the first function that we are going to write down, or that we are going to declare, is the plot elastic net descent path function. So I'm not going to explain it line by line, but what this function does is it returns an image that can be displayed in a Databricks notebook via the display function. So here it returns the image, and then it also saves a figure or an image file called elasticnetpaths.png, right? And then the file is then uploaded to the driver, and then eventually uploaded to MLflow using the log artifact within train diabetes, which is the next function that we're going to show you. So let's go ahead and run this. And the next function we're going to run is the train diabetes model. So I want you to remember because we're going to jump into the training later. The input or the parameters of this function is the actual data, which we created in the previous cell or previous cells. And then you have two inputs, alpha, L1 ratio, which are the parameters that we're going to use for this model. So you have here, you have evaluation metrics that you want to evaluate. And then you have also in the same function, because you supplied the data, we can create the train test split using basically the default 75%, 25% split. And I think what I want you to focus on is the MLflow start run, which Denny also highlighted in the previous session, where you put it under MLflow start run, and things under here are being tracked in MLflow. And you see here that we're fitting and we're creating a model, and we're supplying the parameters. And at the same time, after we evaluate the metrics and get the metrics values, we print them, and also we log them in MLflow. So here, what we log three things. One are the parameters, alpha and L1 ratio. The second is the metrics. We have RMSE, R squared, etc. And finally, you log the actual model. Right. In addition to those three things, we also log as an artifact the PNG file or the image file that you created in the previous function. All right, so this is what this function does, and let's go ahead and run that. So you will see some sample image files here, and we're going to go ahead and do our experiments or do our runs by specifying different values for the parameters that we have defined on the previous cell. Okay, let's start with our experiments. So here, remember the train diabetes function that we declared. It takes, as a parameter, it takes data, alpha and L1 ratio values. So let's start with an experiment having 0.01 and 0.01. So you see, we will have 3 experiments in total, and we will be changing the L1 ratio and see how that affects our metrics. Let's start. So let's run this. So we see it was logged, it was printed out, and it is also logged in the experiment here, this part, right? So remember, we also had an image exported to see visually the elastic net paths. So we see it here, and you would see that, everything is logged, and we will show you later the artifacts and where the artifacts are saved together with the necessary files to reproduce this experiment. So let's do the second experiment. All right, so this time you see that the RMSE, R-squared, and other metrics have changed, right? And let's refresh this. You see that it was logged as well, and you see all the metrics being logged. So this would really help you track what specific metric or what specific parameter led to a metric that is something that you are looking for. So again, let's display the image that was generated. See that it's slightly different. And finally, let's train the diabetes model using a different parameter. Again, if you refresh the experiment runs, you would see here that it was also logged along with the parameters and metrics and the model. Let's look at that. And we see that it's significantly different from the first two. So let's go ahead and look at the MLflow UI. Okay, so there are 2 ways to go to the MLflow UI from the notebook. One is if you want to look at a specific run, or one is if you want to look at the specific experiment with multiple runs. So let's look at the list. So again, if you miss that, I clicked this arrow button or arrow icon to get into this MLflow UI. So here you would see that I have ran this experiment multiple times, and you would see the results, the parameters. Some of them are repetitive, but you get the idea. You can have different parameters and you can have different metrics associated to it, and you can compare them. Right now we only have about 7 experiments or about 7 runs, and so it's still manageable. You can probably go to your notepad and log this and still be sane. But imagine you would have different algorithms, for example, different models, different parameters. Maybe you would have 4 parameters, or you would have more metrics, and you would have hundreds of runs. And really managing that is something that is very tedious, and it's very cumbersome, and it's very inefficient, to be honest. So here you have a single view of all the runs that you did, and you can compare them. Say, for example, you have 100 runs here, and you don't want to compare them all. You just want to compare, for example, RMSE that is, I don't know, less than 70. So you can put here metrics.rmse is greater than 70. Okay. So you can search and see or filter the values or the runs that have only RMSE less than or greater than 70. Okay, so let's clear that, and I want to show you how not just tabular, but you can actually compare all these runs in a chart. So click check and click compare, and you should be able to see kind of on a horizontal view your parameters, your metrics, and each of the runs here. But more importantly, you could see it in a graphical representation, so you can actually pick or you can visually confirm which runs are better than the others. Again, if you are looking into different metrics, you can you can specify them here, and you can specify also the parameters that you see in the X and Y axis of the graph. Alternatively, you would also have some different types of graphs. You have XYZ axis if you want to contour plot, and also you have parallel coordinates plot. So it really depends on how you want to view or how you want to compare different runs for a specific model. Okay, so you can also see specific, if you want to drill down on a specific metric, you can also do that. And you can see here which ones were better than the others. Okay, so let's go back to comparing all the 7 runs. One thing I wanted you to notice as well is you have all the run IDs here. So you can actually go back in time to that specific run. I've showed you how to, and we had 3 runs with different parameters, but essentially you can just go back here and not have run info 1, run info 2, run info 3. You can have one single run and just change the parameters here, and you would be able, and it would log a unique ID that would have the run, which you can go back and forth. As these gets tracked, you can go back to that specific run with the minimum code necessary, so you don't have to create 100 cells with different combinations, right? So this is something, for example, especially if you're using Python, you can even create a script to go through different parameters using a for loop, for example, a loop that you can increment parameters, and so you can have that. You could programmatically create that, and it would generate a specific run, and you can have 100 runs here with a minimum piece of code necessary. So going back to the list, these are all the models that we built. And next we're going to go through the next feature of MLflow, which is MLflow projects, where we can see kind of the artifacts and a standardized project format, which if you're building, depending on a specific framework you're using, sometimes you have different formats for each project. So we're going to look into that in the next section. Okay, so we have this run, the most recent run. You can see that we could go back to the notebook, right, where you ran this specific experiment. Or you can click the date and see details of the actual run. So here, again, I mentioned we have your unique ID for each run. And if you remember, we were logging the model, and we were also logging the image associated to the model that you built. So you can easily go back and see, oh, this is the image that's associated to the current model, and this is what I want to deploy, for example. So again, this could be arbitrary files. You can put a CSV file, if you will. You can, for us, it was more important to see the visual representation or the chart so that we can see what it's kind of a label for this specific model. So we see that this is the current model. You can also see under the model, this is artifacts. You can see in the artifact that you have 3 files here. Let's go through the first one. You see here that the artifact path is a model, right? And you see the flavor here. You see the loader module, the Python version, scikit-learn version, etc. So this is kind of a metadata for you to understand, or if you want to reproduce this in another environment, it's specifically useful for you to learn or for you to know what's inside or what this model is built on. Next is a conda YAML, which is a YAML file that contains, again, dependencies, which versions, which libraries you used. And again, this is for reproducibility and tracking of your metadata of how you built this specific model. And lastly, you have the pickle file, which contains the actual model. And we're going to load this in a minute using a PySpark UDF. And we're going to try to predict the progression of the diabetes by loading this model and running it on a specific sample data. So again, this would have the necessary parameters and metrics that you want to track, and also would have the artifacts associated to this specific run. Okay, so let's go back to the notebook. Okay. You have here the 3 different runs that we just ran, and I just showed you the MLflow UI and how you can interact with it. And now I want to load the model that I built as a scikit-learn model. So how do we do that? So we now import scikit-learn, MLflow sklearn, and we load the model. Okay, so we would like to load the model from run info 1, which is the run, the first one that we had with 0.01 both for L1 ratio and alpha. And we get the UUID, or the unique ID I mentioned earlier. So it's the model is saved on the runs, and then the UUID/model. Okay, so we're going to do that and load the model, right? And so now that the coefficient also is displayed, by the way, and now we want to predict, using a sample data. Okay, so we're using a sample data, and we'll try to predict using the model. So let's do that. So you see here, we made a prediction using a linear regression model. And so we see here that we have the output. Okay, so this is pretty straightforward. But what if you want to use an MLflow model for batch inference? Okay, so you can use here, similar to loading the model using an sklearn load model, you can also use Spark UDF to basically use the model against the sample data, which could be millions or billions of data. So here, we see here that it's very similar to the one above, load model. You put the runs / your UUID / model and load that as a Spark UDF, and use that kind of an abstract Python for MLflow. So now I would like to predict. I would like to use the Python QDF, which is basically a loaded model, and hit it with a data frame. This time it's a Spark data frame with a much larger data, and let's see the prediction. So as you can see, this would generate a Spark job, obviously because it's a Spark UDF, and you would see here that we ran it against a much larger data set, and you would see the prediction results here, and we specified which columns that we were interested in, and we will see the prediction over here. So you have here in the data set, I'm not going to go through detail, but you have the age, the gender, the BMI, etc., and you would have the prediction in the last column. So here, I've shown you how to load a model using sklearn load model, and also loading it as a PySpark UDF function, which you can use distributed processing to make predictions based on your model. Okay, so remember earlier I told you that at some point in the demo, I will switch to the non-community edition of Databricks, which is the full version of Databricks, to demo the model registry. So here we are in the demo environment of Databricks, and some notable differences you would see is the models part here, and this is mainly to give you a list of the models that you have registered. Let's take a look really quick. So you would have all these models and the versions associated to them. So before we go into that, we are gonna first, what we will do is we will register that model through the API. So here you would see that I am creating a new model named Boss 2020, and I've created a client, and I'm trying to register a model if it does not exist. If it does, I would delete it first, and then register the model, just for idempotency. So I go ahead and execute that, and then now I have the model, and I'm going to create the model version. So the version is basically if you build a model and you want to tag it as version 1, and then let's say, for example, someone else builds another model, creates a version 2, etc. So these are different versions of the model that eventually you promote from development to something that you can promote to staging or production. So let's see. We will now create the model version from run info 1, which is our first run of our experiment, and we will associate that into the model name. So, in fact, from this point forward, you would see that the demo here, the code actually talks about transitioning things into production, to staging, etc. And so I thought it's easier or more intuitive for me to show it to you on the UI, which is essentially the same, just interacting through the UI rather than the API. So we're going to go through that for the last 5 minutes of this session. So here, I've created the model, I tagged the version, and now I would like to transition it, right? Transition it to, let's see, I put Boss 2020 here. I'll click that, and I will go to Boss 2020. And you see here that I've created the version, I've tagged the version, and you would see the stage here, right? So I could click on that, right? And so here you have, you can have a schema, you can have activities. It would also give you shortcuts to the run. You can add descriptions, etc., some metadata to help you identify what kind of, let's say, this version was tested against a data that was blah, blah, blah. So you could put that in the description as additional metadata when you make decisions to promote it or demote it. So stages. Stages, I think Denny also showed this briefly in his demo. And so here you have two options. Basically, you have multiple stages: archive, staging, production. This is right now in no stage. So I can transition it to staging, or I can transition it to production, right? So I can also request it if I don't have, let's say you have an approval process to promote things to production. And I assume if you're running a development team, you would have an approval process. So you would have only tested or only models that clear a certain metric or clear a certain requirement go to production. But for the sake of demo, let me show it to you that I can transition it to production, right? First version. So now you'll see that this is actually in production, right? So you can have it, for example, I have a new model and I want to archive this and switch it to archived. You can do that as well. Same thing with staging. As like a normal software development cycle, life cycle, you would have staging, production, and then you can archive it for, future testing, etc. So this is something that you could do with the model registry. And of course, you can go back to your source run. You can go back to the notebook, create a new version. We tried it earlier. Right here, we can create another version and then say put that in staging and have an endpoint that hits that served model and see if that performs better in production and then promote it to production. So this is kind of the concept of what we have in the model registry. And one thing I wanted to show you real quick before I end the session is that we also now have in the Databricks full version a very simple serving API, which you can actually use to serve a model. Let's say you just want to connect it to a dashboard and see how your model performs against the data. So these would be really useful on development phase where you still don't have SLAs, you still have you just want to test it and see how your model performs. So I believe this is still in preview. This feature is still in preview and it's not yet generally available, but in the near future, you would be able to do that all in one platform as well. So this concludes my session, and I hope this was helpful in helping you envision how your day-to-day job or your machine learning, building, development, tracking, etc., could be simplified the life cycle itself would be simplified by using MLflow. Whether it's OSS or if it's on Databricks, then it's in a way it's a zero install. You can use it out of the box. But I hope this was helpful for you to find some ways to speed up and accelerate your model deployment and model development. Thank you, and thank you everyone for listening.
All right, that's it for the tutorial. So this is the time where we have the Q&A session. If you have any questions regarding the tutorial or MLflow in general, please do so. You can either unmute yourself or type it in chat, whichever. Well, we're gonna pick it up and answer the questions.
Hello, nice presentation, guys. So does the model registry is available in the open source version?
The model registry, I have to double check. I think we just recently released it in the commercial version, but let me quickly double check. Denny, do you know if it's available in the open source?
Yes, sorry, I meant to unmute myself. It is actually available in the open source as of, I believe, 1.10, I believe, MLflow. Yeah, so
Great.
The reason why we're sometimes a little confused on the versions is because we will definitely test it out within the Databricks environment first, and so we keep forgetting which version has been pushed out to open source and which is not, that's all. So.
Right.
Okay, thanks.
No, no problem.
Any other questions?
So if there are no further questions, I would like to thank very much Paolo and Danny for their great tutorial. And I would also like to point out that we have a Slack channel. So if you come up with further questions, you can post them there, and then we will forward those to Paolo and Danny, and they can answer you at a later time. So please check out also our Slack channel. We still have a few more minutes, so if you have now some questions, please go ahead. Again, thanks a lot to Paul and Danny. We will make a short break for 15 minutes, and then we will have our next tutorial.